Assalamu alaikum. Welcome to Power Electronics. This is Raid Al Malki. Inshallah, I'm going to explain lecture number 4. Now, according to our schedule, we know that for this lecture we have three-phase, half-wave, three-phase, half-wave, uncontrolled rectifier. Now, let me just revise something very important. Rectifier, we know that when we say rectifier, we are rectifying the signal from AC, right, into DC, okay? Now, also we know that uncontrolled, that we use diode. Why is that? Now, we use diode because we know that in this part we cannot control alpha, and we are going to rectify the circuit from the waveform from AC into DC. Now in half wave for our topic today, we use three diodes. Okay, three diodes. We know that in half wave for the single phase we use one single diode, right? But this is three phase now. This is three phase circuit. Now in three phase circuit we know that we need at each phase we can use one diode, so we have three diodes. That's why we have three diodes. Inshallah, for today we are going to see introduction about three phase half wave uncontrolled rectifier, and we will take an example, and it is very important example for the three phase half wave rectifier. Now this is our circuit here. This is our half wave three phase rectification circuit. Now, as you can see, we have three phase here. This is three phase, 4-wire supply. Why we have 4-wire? Because we have phase A, phase B, phase C, and the neutral. Now, in three-phase half-wave rectifier, we are going to use the neutral. Okay, this is critical to be mentioned, which is that the neutral is there in half-wave three-phase rectification circuit, but in full wave we will not use the neutral. Okay. Of course, there are some advantages and disadvantages. We will, inshallah, discuss it later. Now, let us just revise a little bit about the three-phase circuit. We know that each phase is 120 degrees apart from each other, right? So phase A and phase B and phase C, they are apart from each other 120 degree, okay? And also we know something very important. When phase A is bigger than phase B and phase C, then diode 1 is going to conduct. Diode 1 is going to conduct, okay? So when phase A is positive, right, then we have here, as you know, that this is anode and anode is positive. This is cathode is negative. So when phase A is positive, so positive is connected to the positive, then diode here is forward bias, so it will conduct and it will allow current to move through the diode, okay? Then we have here V diode, of course. Now we have V diode, positive and negative for D1. Okay, and then we know that it is conducting, so the current will go through the diode and it will go through our load, right? In our case here we have R load. Then it will come back to the source through the neutral, okay? This is called V phase. Why the V phase? Because we are taking the phase with the neutral. When I say V line, shabab, then I mean it is line to line between phase A, phase C, or phase B, phase A, and so on. Okay, so when I say يا شباب V line, I mean between two lines. When I say V phase, between the phase and the neutral. Okay, now this is for phase A. Now let us see diode 2 when diode 2 is working يا شباب. Now we say that diode 2 is working when phase B is bigger than phase A and phase C. Okay, so and also when phase B is positive, right? When phase B is positive, the diode here having positive negative VD 2, then it will be forward bias and it will conduct the current. It will move the current. It will go from this side to the load, right? It will go through the load and it will come back to the source through the neutral. Now, of course, the current, it will not move from here and it will not move from here as well. Now, why is that? Think about it a little bit. Of course, the current cannot go through D1 and D2, D3, because now we have, as we said, we have here positive, right? And positive, and this anode, this cathode, sorry, is negative. So here, it cannot go from here. Because why is that? Because now diode 1 and diode 2, diode 1 and diode 3 are reversed bias. So when the diode reverse bias is acting like open circuit, so the current cannot go through D1 and D3. That's why the current is going through D2 and to the load, and then it come back to the neutral. Now this is for D2, right? Now for D3, we know that the D3 will conduct when VC is bigger than VB and VA. Okay, and why VC is related to to D3 شباب؟ ليش؟ لأنهم they are connected here شباب. So diode 3 is connected to VC. That's why we need to mention very important thing, which is when VC is higher than VB and VA, D3 is going to conduct. D3 is going to conduct. So when the VC also is positive, okay, when VC is positive, then D3 is going to conduct because it is forward bias, because we have here VD3, right? So it will be forward bias, so the diode is going to conduct and it will allow the current to move from this side to the load, right? And it will come back to the source through the neutral. Okay, I'm saying neutral شباب. I'm saying neutral because I need to focus that the three-phase half-wave rectifier, it has a neutral line. Okay. Of course, it cannot go through D2 and D1 because it will be D1 and D2 will be reverse bias and they will act as open circuit, so current cannot move through D1 and D2. Okay. Now I put here paragraphs يا شباب. You need to read them in order to understand more about the three-phase. Now let's go to this second slide. You remember يا شباب, I said when VA is bigger than VB and VC, D1 is working, صح? Now this is our V source. Sorry, this is our V source. Okay شباب. This waveform is for the V source. Okay, this form is for V output DC. Okay. Now, Shabab, tell me where the VA is bigger than VB and VC. Now, let me just choose green color. Now we can see that in this period from 30 up to 150, VA is bigger. Now why VA is bigger يا شباب? Can you see VC here? This is VC, right? And this is VB. They are, as a value, they are less than this value, right? They are less than this value. So VA in this part يا شباب, VA is bigger than VB and VC. Right يا شباب? That's why we have an output voltage here, an output voltage, and in this output voltage we know that D1 is conducting. D1 is conducting. Okay? Now, we know that diode 2, it will conduct when VB is bigger than VA and VC. And we know at this part يا شباب, at this part from 150 up to 270, VB is bigger than VA and VC as a value. So this is our value for B, and these are our value for C and A. So B is bigger. Okay, that's why we know that it will conduct. Okay, and there will be a value as an output voltage, and we know that D2 is working in this period. Okay, now for the third one, we know that D3 is working when VC is bigger than A and B, and we know in this part يا شباب, we know that VC is bigger than VA and VB. So VC is working يا شباب, VC. So D3 sorry is working. D3 is working at this part. So this is our three-phase output. Now this is the output voltage VDC. Okay, so if we finish at 360, because we are saying that it is one cycle, right? So we need to focus on one cycle only. In this one cycle, we know that this is VD3, right? Until here, huh? Until here, it will continue here. So this is also D3. Okay? Now, D1, D2, and D3 for the three-phase half-wave uncontrolled rectifier. Now, again, why we are using one cycle? Because we know that we need to focus on one cycle to have the readings for the D1, D2, D3. And we know one cycle is one complete cycle. It will start from 0 and end at 2 pi, or we can say 360 degrees. We know that period is 1 over frequency, right? And we know that the frequency is number of cycles per second. Okay, number of cycles per second. So for phase A, this is our cycle for phase A. It will start and it will end at 360, right? Okay, so this is one cycle, and the frequency now for this one is one cycle per second, so 1 per second. And if we need to find the period, it will be 1 divided by 1, which is 1 millisecond, 1 millisecond. Okay, because sorry, 1 second, sorry, 1 second. Now also we can refer to this paragraph يا شباب in order to understand more about the three phase. And this is for the voltage A, right? This is for voltage B, and this is for voltage C. We know that V peak here and this is the sine, and this is omega t. Omega t, of course, is here, right? And this is angle 0. Why phase A is angle 0, the shift angle for phase A? Because it will start from 0. Why VB is starting from 120? Because of course we know that each phase and other phase they are 120 degree apart, and also phase A, phase B and phase C, they have difference of 120 degree, or we can say between phase A and phase C we have 240 degree as it is written here. Now, for the three-phase half-wave and control rectifier, we know from our notes, يا شباب, these are the formula for our for the three-phase half-wave rectifier. Now, this is our formula. Why we have three here, يا شباب? This is for the V out DC, huh? V out DC. This is how to calculate V out DC, يا شباب. Now we have three because of the three diodes, right? Now we have root 3 multiplied by V maximum line to neutral, because we are working in three phase, right? So we know that three phase here should be line to neutral. So we multiply root 3 by V maximum line to neutral, and it is divided by 2 pi. Why 2 pi? Because we are working in one cycle, right? Sorry. Now this is for the V out DC. Of course, the rest of our the rest of the formulas are just only sorry, are Ohm's law. Okay. Now again, it is the same here, شباب. If you can see here, شباب. Now VDC. Now we know that the number of this of these numbers should be 0.8727. You can multiply by the V peak line to neutral. V peak line to neutral. So you can use this formula also. خلاص? Now let us see the phase shift between the diodes. So if I ask in the exam, what is the phase shift between D1 and D2? You can say it is 120 degree. D3 and D2 also the phase shift is 120 degree. What about D1 and D3? It should be 240. Okay. Please refer to the notes for the three-phase half-wave and controlled rectifier from pages 22 to 27 in order to see the voltage of diode 1, voltage of D2, and voltage of D3, and so on, and the currents, how we can draw them. Okay, how can we draw them? Now for the three-phase, let us draw together the three-phase the output for voltage DC. Okay, now I will show you how to draw them. Okay, let us just put the x-axis. Let us assume the x-axis is here. Okay, and the y-axis is here. Okay. This is 30, this is 60, this is 90. Here we have 90 degree. Okay. Now each box is 30 degree. Okay. Here 90 plus 30, which is 120. Here 150. Here we have 180, right? So this is 180. And this is after 90 degree. We have 1, 2, 3, 1, 2, 3. This is 270. 1, 2, 3. This is 360 degrees. Now this is with the omega t, right? And here we have V output. Sorry, this is V source here. This is V source. Now let us see our V source. We can start by having red color for VA, right? So this is our, of course it will start from 0 and its peak will be at 90. So this is our peak, okay? And it will return to 0 and then it will go to the negative peak. How many peaks we have here? 1 box, 2 box, 3 box, 4 boxes, right? So we can count 1, 2, 3, 4 boxes. So this is our negative peak for the for phase A. Sorry, it should be 270. 1, 2, 3, 4. Let me just do it again. Do it again. We'll do it again. This is 180. This is 270. Okay. As we said that it will start from 0, its peak will be at 90, positive peak, and it will come back to the negative. And we know that its peak here, we're supposed to have 4 boxes, right? So at 270, it should be having 4 boxes also. So here will be its negative peak, and it will come back to the 0 here. So we can draw like this from the positive peak, and it will come back to here and then here. Okay, and this is how to draw, ya shabab. This is how to draw in the exam, ya shabab. This is for the first phase, which is phase A. Phase A. Now let us draw phase B. Let us draw phase B. Now we will use the green color. Okay. Okay. Now we know that phase B, it will start from 120 degree, right? So this is 120 degree. So its peak, it's 0. It will start from 120 degree. Okay. Then we can go for 3 boxes, right? Remember, this is 1, 2, 3. So its peak is here. Why 4 boxes? It should be the same as the first phase. Now this is its peak. Now let us go to 0. So we can count 1, 2, 3. This is its 0. It should be here. And we can also complete the waveform. It should be 1, 2, and 3. So its peak should be here. But this is out of one cycle, so we can complete it together. So let us draw it together. Now this is for phase A, phase B, sorry. This is for the positive cycle, and we can complete, yeah, and let me do it again. It should be here, right, shabab, the peak. So it will complete like this, and it will be like this. خلاص. So after here, shabab, after the 360, so we will see just only one cycle. So this is after 360. We can put like dots. Okay. Now let us complete and go back for here, shabab. Now we know that the peak is 1, 2, 3. So this is 1, 2, 3 boxes. So this is the its peak. So we count 4, 1, 2, 3, and 4. This is its peak, right? So we can complete the waveform. Okay. Now let us complete the waveform. So this is 1, 2, and 3. So it will stop here. We can draw like this. And dots outside. Now this is for phase B. Now let us see phase C. We can draw by blue color. Now for phase C, it will start after 240 from phase A, right? 240. So this is 270, this is 240. It will start from here. This is 270, this is 240. This is 240 here. Its peak is 1, 2, 3. We can count 3, and its peak is here. So we can draw line here. طيب, we can go to the 0. This is 1, 2, 3. This is after our wave, so we can make dots after the period. Now let's complete from the back side. We know that it is 1, 2, 3. So its peak is here, right? No, it should not be here. It should be here because we have 4 boxes, right? So we can complete our waveform. And let's go to 0. This is 1, this is 2, this is 3, and this is it's 0. We can return back here to 0. And let us count also 3 boxes in order to see its peak. So this is 1, this is 2, this is 3. So its peak should be here. Okay, so this is after the 1 cycle. So we can okay, so this is our waveform, and this is for VC. So these are the 3 phases. Now let us see now V8. Sorry, V output DC. V output DC. It should be like this. Here we have V out DC. Now let us see how to draw the V out DC. We use the red color. Now we know that when V is bigger than VC and VB, then it should conduct, right? And we should have output voltage. Now this is our at 30 degree, right? We have 1 box, 2 boxes from here. So at this 30 degree, so 2 boxes from here. We can count 2, and this is our peak. We count also 2, and this is our lower point. So we can draw our waveform. Okay, this is phase A, or we can say this is diode 1. Diode 1, it will conduct in this portion. Okay, now for diode 2, again we count 1 and 2. This is its peak, and 1, 2, this is its lower point. So we can draw the waveform. Now this is for D2. Now for D3, we can count 1, 2, its peak is here, and 1, 2, it is out. So we can complete our circuit here, our waveform. Okay, and also it will return from here. Now let us count 1, 2, should be here the maximum, and this is our so in this part we have D3, and of course this is the completion of D3. And we can conclude from this waveform that at for D1, the conduction angle is 120 degree, and also here 120 degree, and also here is 120 degree. Okay, because this one is from 270 to 360, we have also 30, so this is our 30 here, this is our 30. Now this is how to draw the V out. Now let us see the example for our topic today. This is our example. This is question 6 in your notebook. You can refer to page 38 to see the question. Okay, now three-phase half-wave rectifier, uncontrolled rectifier, has a purely resistive load which is 10 ohm. It is supplied from line to should be line to neutral يا شباب, line to neutral. Yeah. Now, but in this question, he gave us line to line. Okay, so its line to line is 240, and it is at 60 hertz degree. Okay, now determine the output ripple frequency. Now we know that the ripple frequency ripple is equal to source frequency multiply number of pulses. So it will be 60 multiply number of pulses. We have 3 pulses as output, right? So 3, so it should be 180 hertz. This is the ripple frequency. This is the ripple frequency. Okay, now this is for A. For B, he said that find the average load current. The average load current. The average load current, when I say average load current, I mean V output DC. V output DC. So V output DC, as we said here, and we can see here, شباب, it should be 3, okay, multiply root 3 V maximum line to neutral divided by 2 pi. Now we know here يا شباب that V maximum line to line is equal to what? Root 2 multiplied by 240. So our line to line voltage should be 339.4 volts. This is our maximum. Okay, this is our maximum. طيب. Now this is very important question. Do we have here in this question? Do we have V line to line, or we have in the formula we have V line to neutral, right? Okay, so we know from circuit 2 that V line to line, remember شباب, root 3 V line to neutral or V phase. صح ولا شباب? That's why we can say we can remove this part and use V line to line. But maximum, huh? So it should be like this, 3. We can substitute here. So V maximum, 3 V maximum line to line divided by 2 pi. Okay? So that's why it is equal to 180 62 volt. Now this is for the average output voltage. This is our average output voltage. Now let us see the current. Let us see the current. Now we did not finish because we need to find the current. Current I out DC is equal to 162 divided by R, which is 10. So it is equal to 16.2 ampere. خلاص. Now this is done. Okay, you can see the formula here, and this is from Ohm's law. Now what about the maximum diode current? The maximum diode current. Imax. Imax is just only I maximum is just only V maximum divided by R. V maximum divided by R, and V maximum is 339.4, okay, divided by 10, and which is equal to 300 or 33.9 ampere. Okay, this is for C. For this is for C. For D, the diode conduction angle. The diode conduction angle, which is D here, right? Diode conduction angle is just simply gamma is equal to 120 degree. As simple as that. Okay. Why 120? We know it will start from here, شباب. If you can see here, it will start from 30 up to 150. We know that at 30 we have beta, alpha. So alpha here is 30, and it will end at beta 1. Beta 1 is equal to 150. So gamma is equal to 150 minus 30 degrees. It will equal to 120 degrees. Okay. Now this is for D. Now the average load power, which is B out, of course, DC. So this is for for E, sorry. B out DC is equal to I out DC multiplied by V out DC. Okay. So this is our formula, شباب. It will be equal to 162 multiply 16.2, which is equal to 200 or 2624 watt, شباب, watt. Okay, this is for E. Now for F, شباب, for F, he said the number of output pulses. It is 3 pulses. So it is 3 pulses. Now for G, he said the average diode current. Now, how many diodes do we have, شباب? In this part, we have 3 diodes, right? So I average diode is equal to I output DC divided by 3, because we have 3 diodes. So 16.2 divided by 3, which should be 5.4 ampere. So if I say give me the average diode current, you should divide by 3, because we have 3 diodes. I output DC divided by 3, and so at each diode we know that the current through them is 5.4 ampere. Now this is all about our lecture today. I hope that you understand everything. If you do not understand something, يا شباب, you can contact me through our Telegram group or through the Blackboard. You can send me email, and inshallah, once I receive your question, inshallah, as soon as possible, I'm going to respond to your questions. Thank you so much for attending this lecture, and stay safe.